Hey there, students. In this video, we are going to talk about dividing monomials. So our learning target today is I can simplify polynomial expressions by finding the quotient, which is the result when you divide. And we're going to find the quotient of two or more monomials. Previously, we've looked at adding and subtracting polynomials and then multiplying polynomials. So before we get into dividing monomials that have variables, let's first look at numerical expressions with exponents that we can divide so we can kind of grasp the concept a little better. So here in these two examples, we're actually going to do this in the calculator, and then I'm going to show you an alternative way to get that same answer, the way in which that we're going to use for the problems with variables. So this problem number one, it's 5 squared divided by 5 cubed, and we want to evaluate that and see what the answer is. And so let's do that together in our calculator. So in your calculator, go home and then new document, and you want to add a calculator. And since we are typing in the fraction, let's do control divide. And the problem was, let's go back. It was 5 squared divided by 5 cubed. So if I have 5 raised to the second power, and I want to divide that by 5 raised to the third power, I see that my answer is 1/5. And so let's talk about how we get that answer without using the calculator. So we should know that anytime we see an exponent, those are instructions, and this 2 is give me instructions on what to do with this 5. So 5 squared simply means 5 times 5. And in the denominator, I have 5 cubed, and that tells me 5 times 5 times 5. And so we know from an earlier grade level that anytime I have a value divided by itself, that result is going to be 1. So I can see that I have a 5 in the numerator here, a 5 in the denominator here. I know that this is going to cancel out and to be a wonderful 1, but I also have that same relationship here. So that's going to cancel out and become a wonderful 1. But now all the 5s in the numerator have canceled out, which means I only have 1 left in the numerator, but I have a single 5 in the denominator, and when I take this 5 and multiply it by the 1 over here, and so that's how we get 1/5 in the calculator. And so still we can utilize the concept of expanding this out like we did with multiplying the monomials, but now that we're expanding, we're going to look at what can we cancel out to help us get our final answer. And so let's look at another example here. 4 to the 4th power divided by 4 to the 2nd power. So if I continue the process of expanding this out, I should know that this 4, the exponent, is telling me that I'm going to take the 4 and multiply it by itself 4 times. And then in the denominator, the 4 squared, so the exponent of 2 is telling me that I'm going to multiply this by itself twice. And then before I get my answer, I'm going to see what can I eliminate, what can I cancel out. Well, I have a 4 in the numerator, a 4 in the denominator. That cancels out to a wonderful 1. I have that same relationship here, a 4 in the numerator and a 4 in the denominator, so I can cancel that out. And I am left with just 4 times 4. So when I write my answer, well, 4 times 4 is 4 squared over 1, or divided by 1, and that's just 16. And so I can do that because this is a number, but if this were a variable, I would leave it as 4 squared. And if I wanted to check that, let's go to my calculator, control, divide, 4 to the 4th power, and then in the denominator, I have 4 to the 2nd power, and we get 16. So now let's take this process and let's see if we can add this to problems in which we have variables like x to the 6th and x cubed, and see if we can simplify this expression. So we want to write an expression equivalent to this. And I'm going to utilize the same method, which is expanding it out. So in my numerator, I have 36 and then 6 x's. And in my denominator, I have 12 and I have 3 x's. So in my answer here, I'm going to look and see what can I eliminate amongst the variables here, the x's. So I have 6 x's in the numerator, I have 3 x's in the denominator. That means that this is a wonderful 1, this is a wonderful 1, this is a wonderful 1, and I have left over 3 x's, and they're all in the numerator. So I know that those 3 x's are going to stay in the numerator. And that's going to become x cubed. Now, I also can simplify this 36 and this 12. I can reduce that because this is 36 divided by 12. So if we're not sure what 36 divided by 12 is, let's go 36 divided by 12, and we get 3. So if I go back to my little fraction here on my problem, this is 3. This is 3 divided by 1. Or, I don't really need that 1 in here, so it's just 3x cubed will be my final answer. So 3x cubed is equivalent to this ratio here, or this fraction here. So let's do another example before I have you try it on your own. So again, we're going to utilize the expanding it out. So I'm going to draw my little fraction bar. And then in my numerator, I'm going to rewrite 3. And then this squared tells me I have x times x. And then in my denominator, I have negative 9, x to the 5th power. So this x to the 5th power tells me that I'm going to have 5 x's. And then we simply go through and we reduce it. So if we want, we can think about how many x's can be eliminated from the numerator and the denominator. So there's 2 x's in the numerator. There's 5 x's in the denominator. So I know I can eliminate that pair and this pair. And my x's that remain are only in the denominator. So if I notice, there's no more x's in the numerator, just this number 3. So these x's that remain are in the denominator. So in my answer, I'm going to make sure I keep the x cubed in the denominator. But part of my answer is from this 3 divided by negative 9. So I need to go ahead and simplify this so I can write it as part of my answer over here, like I did with the 36 and the 12. So if I go to my calculator and I take 3 divided by negative 9, well, I get negative 1/3, or negative 1 divided by 3. So I go back to my problem, and that is going to be negative 1/3. And so this is my answer that I would get for this problem. So now I'm going to have you try 2 on your own. So these are your 2 problems. I want you to try and simplify the first one, just like I did on the previous example, and then simplify the second one as well, just like I did on the previous example. So now that you simplified the first one, this is what the work and the answer should look like. If you did not get this and you have trouble, feel free to ask for help. And then this is how the work and the answer should look for the second one. So again, if you did not arrive at this answer, or you didn't have this work, please ask for help, stop the video, and then I will explain how I arrived at this answer and how I arrived at that answer. All right, so let's see if we can increase the difficulty level of these problems. Now we looked at dividing monomials when there was only one variable. Now we want to look at dividing monomials when there are 2 variables. So here we have x and we have y. The process is more or less the same as before. So equals, I'm going to use the expansion method here. So draw my fraction bar. I have 24, and then x squared means x times itself twice, and y cubed means y times y times y. All of this is in the numerator. And then in the denominator, I'm going to also expand this out as well. So 16x, and I have 5y's, because it's y to the 5th power. And so now I can go through and see what can be eliminated or what can be canceled out into a wonderful 1. And we notice that, hey, there are 2 x's in the numerator, but there's only 1 x in the denominator. That means I can only cancel out one of the x's in both the numerator and the denominator. So that leaves me 1 x up here. There's 1 x left over. And that 1 x is going to go here. And so when I look at my y values, I have 3 y values in the numerator, and I have 5 y values in the denominator. So when I cancel that out, I can cancel out that pair of y's, I can cancel out these, and I can cancel out those. So the 3 y's, all of the y's in the numerator were eliminated by these 3 down here. But look, we have 2 left. That means I have y squared. Now, I'm not finished yet because I want to take care of the 24 and I want to take care of the 16. So this can be reduced. It can be simplified. If you're not sure how to reduce that, well, go to your calculator and I can do 24 divided by 16, and it's 3 divided by 2. So in my answer, I'm going to have 3 halves. And this will be the value that is equivalent to this one. So let's try one more. Let's try one more example, and I'll have you try 2 on your own. So if I expand this out, I have 9, and then I have 4 s's and a t. And in the denominator, I have 18, 1 s, and I have 3 t's. So when I look at eliminating some of my variables here, well, I have 4 s's in the numerator. I have a single s in the denominator, so I know that that's going to cancel out one of them. And that's leaving me 3 s's in the numerator. So over here, that's going to be s cubed. If I take care of my t's next, so I have a single t in the numerator. I have 3 t's in the denominator. So that means I can eliminate one of those t's from both the numerator and the denominator. And I have 2 t's remaining in the denominator. So that is going to be t squared when I put it back together. Now we're not finished because I have to take care of my coefficients here, my 9 divided by 18. And so if you're not sure what that is, go to your calculator and do 9 divided by 18. And we get 1/2. So if I go back to my problem here, this is going to be 1/2. And so this answer is equivalent to this answer here. So now I'm going to have you try 2 as well. So I want you to look at these 2 problems, and I want you to simplify them the same way that I did through the expansion process. Or if you know another way, you can try that as well. And I'm going to go over how the answer should look. So this should be the work and the answer for the first problem that you were to try on your own. We see that this is equivalent to 1y divided by 3x to the 4th power. And for the second one, this is the work in how you get this answer here. So 4mn squared divided by 10m cubed n is equivalent to 4n over 1m squared. And so that's pretty much it as far as dividing monomials go. We're just expanding it out and then trying to cancel out the variables from the numerator and the denominator, and then whatever is left, we put it back together as either a fraction, like this, or if there's no fraction, it could be a whole number. And so the last thing I want to talk about is 0 exponents. So this is going to be fairly quick. In your calculator, you can type in any number and you can raise it to the 0 power, and it will always be 1. So if I do 852 raised to the 0